Alright, welcome to Cardinality. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. Start with some definitions. If A is a finite set, so we can count how many things are in there, then its cardinality is given by the number in A. So n meaning number, we're going to count how many are in set A. It just stands for the number of elements in A. If S is a finite universal set, and A is a subset of S, then the number not in the number not in A plus the number of things in A have to add up to everything in the universal set. So it's either in A or it's not. There's no in between. Black and white. A, not A. That's it. So this equation can be manipulated to solve for any of the single ones. If you want to know the number in A and you know the number in the complement and the universal set, you can do some subtraction instead. For finite sets, the number in a cross product is the product of the number in each set. So the number in A cross B is the number in A times the number in B. And if A and B are finite sets, we have a union rule of counting. The union rule of counting says the number in the union is the number in A plus the number in B minus the number in the intersection. Let's see why that is. Suppose we have a universal set S. We have the set A. We have the set B. And we want the union. But look what we do. When we count everything in A, see how we count this intersection piece once, right? When we count everything in A, we have naturally counted everything in this intersection. But then when we count the number in B, we're counting everything in this circle. Oh look, we're double counting here in the intersection. That's cross-hatched. I counted everything in A, I counted everything in B, so everything in this intersection has been counted twice. So what we're going to do, let's see if I can do this correctly here, is I'm going to take out this second counting. Oh man, yeah, it's not going very well for me, is it? I'm going to take out this second counting, so I only have this part that's overlapped once, and so that's my erased portion here. I take out one version of the intersection because I've already counted it once. I don't want to count it twice. Now everything's only counted once. Kind of ugly, but I hope you get the point. So my pronunciation, very bad. I'm going to use first letters. Let A be the set containing D, J, F, and S. B is the set F, S, T, K, and H. C is the set Hans and Franz, different from this H. Find the number indicated, so the number in A plus the number in B. Well, how many names are in the set A? 1, 2, 3, 4. How many names are in the set B? 1, 2, 3, 4, 5. So 4 plus 5 is 9. That's it. The union rule of counting, keep in mind that the number in A was 4. The number in B was 5. And then how many do they have in common? So A and B both have Franz. And they both have, I'm going to go with Sari. I don't know, that's how I pronounce it. So that's a minus 2. So we have a 4 plus 5 to give us the 9 minus the 2 that I counted twice. So we'll subtract off one set of 2 and get 7. Let's see. In the union, I'll have 1, 2, 3, 4. Already listed those. 5, 6, 7. Yep, seems to be legit. Now, the number in A union, B intersect C. This is the union rule. This is the number in A plus the number in the intersection of B and C minus the number included in all of them. So we have the number in A is 4 still, yes. The number in A is still 4. B intersect C. Let's see. B and C have Franz. That's it. They only have one in common. And what do A, B, and C have in common? The only thing B and C have in common, maybe we'll use red on this one. B and C have fronds in common, but look, that's in the set A also. The same one here that was intersected with B and C is the same one that also intersects A. So it turns out you just get the 4 elements of A, and whatever B and C has in common, also in that set. Whew. Alright, so let's see the outcomes of flipping a coin, heads and tails. D is the set of outcomes of rolling a standard 6-sided die, 1, 2, 3, 4, 5, 6, and P, set of primary colors, red, yellow, and blue. If I wanted to find the number in C cross C, that is the number in C multiplied by the number in C, 2 outcomes when I flip a coin, and 2 more outcomes when I flip a coin. 2 times 2 is 4. If I'm rolling 2 dice, the number in D cross D is the number in D times the number in D. There's 6 outcomes each time. It's a total of 36. If I wanted to flip a coin and then choose a color, then that's the number in C is 2. The number of primary colors is 3. We have 6 different options. The number in coin cross dice cross primary color, we just find the number in each one and multiply. 2 coin flips, 6 die rolls, 3 colors. So that's flipping a coin, rolling a dice, and then spinning a spinner to choose a color. 36 total outcomes that we could have there as well. Cardinality, counting. We use the N for number of. Pretty short lecture, but thanks for listening.